Okay, welcome to the electric charge and static electricity review video. I'm going to start by go ahead and advancing this. Pictures of the atom are here because the atom is crucially important with electric charge, because electricity has to do with one particle mainly, and that particle being the electron. Charged particles overall, but the electron is the main culprit. So what is electric charge? Well, it's a property that causes subatomic particles, mainly protons and electrons, to attract or repel each other. In fact, it's entirely protons and electrons because neutrons have a neutral charge. Protons have a positive charge, and of course electrons have a negative charge. So this is where the charges start to interact. Any molecule with more or less electrons produces an overall electric charge, and we call these molecules ions. This is a review from atomic structure, if you recall. A neutral atom has the exact same number of protons that does electrons. In the example provided, you can see there's 7 protons here. 1, 2, 3, 4, 5, 6, 7. And there are 7 electrons, 2 in the first and 5 in the second ring. This atom is neutral, but if an atom gains or loses electrons, it becomes an ion. Protons stay the same, but the electrons are really what's changing. If you have an extra electron, it becomes an overall negative charge. Why? Because you have an extra minus charge. If you lose an electron, then all of a sudden it becomes a positive ion or positive charge because you've lost one of the negatives that balance out your positive and negative in the overall atom. Electric forces. Like charges repel each other, and opposite charges attract each other. So positives and positives will repel or go away from each other. Negatives and negatives will repel or go away from each other. This diagram right here says it all. And negatives and positives will attract to each other. These are a couple of examples showed in class. A couple of balloons. If you charge both balloons, they become overall negative and they will repel each other. If you remember the online example I used with the balloon and the sweater. Inversely, the balloon and paper will attract to each other because if you charge the balloon, then it becomes overall negative and the paper jumps to it as a result of that. Because the paper has both positive and negative charges. The electric field. It is the effect that electric charge has on other charges in the space around it. Really, the space around it is the key. Electric charges don't necessarily have to be touching each other. In fact, they don't touch each other in order to interact. But they interact through space. Strength of the field depends on 2 things. 1, the amount of charge that produces the field, or how many charges you have. For instance, if you have 4 pluses, right, that's going to create a pretty good charge. It's going to create a stronger charge than 1 plus. And the distance away from the charge. If there's a plus way up here and then a minus way down here, they're still going to be connected, but there's going to be a very weak signal. If the plus were here, if the plus were here where this one is, and the minus is here, it's going to be a much stronger electric field in between these things because they're closer together. Works very much like gravity, if you recall gravity. The more mass you have, the more gravity you have. In just the same way, the more electric charges you have, the stronger the electric field, as well as the distance part of gravity too. Closer two massive objects are together, the more gravitational force is exerted. Alternatively, with electric fields, distance decreases, strength decreases with distance as well. The closer two things are, the stronger. The further away, the weaker. Electric field lines, in the positive sense, point outward, like this. You can see this example here. Negatives point inward. Well, These point out and they come into this one, right? These point out and come into this one. It works as a big loop. And anything within the loop, if you will, is affected by the electric field. Static electricity is the overall study of the behavior of electric charges. We've basically identified what electric charges are. Now, what is static electricity? It's just the study of it, right? We recognize that it's a force and people study it. 3 different ways charges can be transferred. By friction. Good example of that's balloon and hair or balloon and rabbit fur. You have to rub it, right? Rubbing is the key here, friction. Friction and conduction oftentimes get confusing because you think, touching a balloon to hair is not going to cause the static electricity to build up on it. It does not steal the electrons. Friction requires that there needs to be movement. Conduction, on the other hand, does not require that there's movement. It just is the touching of something else that's charged. For instance, a balloon that's already previously been charged touching something else, like the wall, in this example. If you remember the Van de Graaff generator from class, when you touch the Van de Graaff generator, you're conducting static electrical charges. And the last one is induction. Occurs when charge is transferred without contact. The hand and your doorknob, if you've ever shocked yourself doing that, that charge is transferring through induction, through the empty space, without contact. Additionally, if you remember when we did the Van de Graaff machine, it would shock you before you actually got up there to it when the charge was great. It would reach out and induct to you. So, trying to think of another good. Oh, the Coke can. When I moved the Coke can in class with the charged balloon without touching it, that is also induction. So 3 ways: friction by rubbing, conduction simply by touching, no rubbing, and induction is when there's no contact whatsoever. The last thing we'll talk about for this video is static discharge. Well, these charges build up and they want to discharge. What does discharge mean? I mean, it means exactly what it sounds like it means. It means to give away those charges or to put off those charges. So, depending on what you have charged up, it will discharge in different ways. When you get shocked from a doorknob, that is discharge through induction. Or it could be discharged through conduction, depending on if you actually get to touch it before it discharges or if it reaches out and touches your hand before you touch the doorknob. Another good example of static discharge is lightning. Lightning is buildup of charges between water molecules in the storm and the air molecules that are in the, just naturally in the air. And as these kind of rub against each other, causes a lot of friction. And when you have a lot of static charges passed by friction, they discharge greatly. Obviously, a lightning bolt is a great example of static discharge, but it's a really powerful example of static discharge. So, getting rid of the charges. They build up, it has to get rid of them. Anyway, this has just been a quick review of electric charges and static electricity. I hope it helped. And I'll see you in class.